The SI base unit for temperature is now the Kelvin. In 1848, an Irish physicist named William Thomson Lord Kelvin wrote about the need for an absolute temperature scale. Knowing that temperature was related to the motions of molecules, Kelvin reasoned that there must be some temperature at which all atomic and molecular motion would stop. He called this temperature absolute zero. Nothing could be colder than absolute zero, because it would be impossible to have less motion than no motion at all. The Kelvin temperature scale starts at absolute zero, 0 degrees Kelvin, which Kelvin calculated as negative 273 degrees Celsius or negative 459 degrees Fahrenheit. Okay, we grew up thinking that temperature means how hot or how cold, but what it actually is how fast the molecules are moving. The faster they're moving, the higher on the temperature scale it is. The official SI unit of temperature is not a degree Celsius, it is a Kelvin. Kelvins are not written as degrees, they are written as K without the degree sign, like this. So 0 Kelvin. A lot of times I say 0 degrees Kelvin, and if you say 0 degrees Kelvin or you write 0 degrees Kelvin, that's fine for now. In your college classes, you're not going to want to, but sometimes it's hard for the first time to remember that that's temperature without the degrees sign. So you'll see it with and without the degrees. If all motion were to stop, the temperature would reach 0 Kelvin, which is negative 273 degrees Celsius, or absolute zero. The Kelvin scale is named after Lord Kelvin. So they're looking at molecular motion, and then they extrapolated down to zero because, like I said in the first recording, they have not had that happen, and as some physicists believe, that's a good thing. Metric system units are based on powers of 10. Metric units can be divided into smaller units or multiplied into larger units based on factors of 10. Those factors can be represented by specific prefixes. Here are some examples of other metric units. 1 centimeter, cm, equals 1/100th of a meter, or 0.01 meters. 1 millimeter, abbreviated mm, equals 1/1000th of a meter, or 0.001 meter. 1 micrometer is abbreviated mu. Yep, that's what that funny looking mu is. It's the Greek letter mu. So mu m equals 10 to the negative 6 meters. 1 decimeter dm equals 1/10th of a meter. 1 kilometer equals 1,000 meters. 1 kilogram equals 1,000 grams, because kilo means 1,000. 1 milligram equals 1,000th of a meter, or 0.001 grams. Prefixes that are most commonly used in chemistry include kilo, centi, milli, micro, and nano. So you might have heard of some of like the iPod Nano, meaning the really small one. Nano is 10 to the negative 9th. Very, very, very tiny. For example, 1 microgram equals 1/1000th of a milligram, or 10 to the negative 6 grams. Metric system. And you can go ahead and look this over. You can see we have nano, we even have pico, and femto, so it gets even smaller. We can get even larger than kilo for mega, giga, tetra. And again, you've heard these terms, a megabyte, a gigabyte, a tetrabyte. Okay, those have the meanings of mega million, giga billion, tetra trillion. So trillions of bytes for your computer memory. There are several other metric base units. In addition to the units for length, mass, and temperature, there are a few other metric base units. We can use the ampere, abbreviated capital A, is the unit of electric current, important in discussions of electrochemistry. The candela is, candela is how they pronounce it. I grew up with it, candela, but candela is the unit of light intensity, so how bright something is. The mole, abbreviated MOL, amount of a substance related to the number of atoms or molecules. Moles will be important in your study of chemical equations and gas laws, and we'll talk more about moles later. And the second is the unit of time. This is the only unit that is not based entirely on 10. Time is the same as in the English system. 60 seconds equals 1 minute. 60 minutes equals 1 hour. Type of measurement. You need to know length is measured in meters, abbreviated M. Mass, measured in kilograms, abbreviated kg, or it can be grams, abbreviated G. Temperature is in Kelvin, abbreviated capital K. Time is in second. abbreviated lowercase s. I don't think we use amperes at all in chemistry this year. Moles, amount of substance, we'll get to more. Luminous intensity, but we don't really use that either. Okay, so it's the top ones that you need to make sure that you know. The metric system is a scientifically based decimal system of measuring. The SI or metric system has 7 base units: the meter, kilogram, Kelvin, ampere, candela, second, and mole. It also has derived units, which are combinations of the base units. All right, so on the quiz, what you really need to know is what I showed you in the pre-reading. You need to know meters is length, kilograms is mass, seconds is time, Kelvin is temperature. You need to know water boils at 212 degrees Fahrenheit, which is the same as 100 degrees Celsius. You need to know water freezes at 32 degrees Fahrenheit, which is the same as 0 degrees Celsius. You need to know absolute zero. The temperature is related to the motion of molecules or atoms. Absolute zero is the temperature at which all atomic and molecular motion stop. It's the only time atoms stop moving. Absolute zero is 0 Kelvin, which is 0 K, or negative 273 degrees Celsius, or negative 459 Fahrenheit. You don't need to memorize those. Know that it's 0 degrees K. Know how much kilo. So kilo is 1,000 meters. Milli is 1,000th of a meter. Make sure you know all your abbreviations. And then also in the notes, I just kept the beginning part, but that's not on this quiz. The main part of this quiz is this: metrics. You need to be able to convert. So if I have 75 meters, you need to tell me how many kilometers that is. So I'll go over an example of this. And there is a metrics worksheet, which you need to do unless you think, yeah, I'm going to get a perfect on this quiz. And if you don't get a perfect on this quiz, go back and do that worksheet because it's going to help you all year. All right, so base. Base is our meters, grams, or liters. You can have a kilometer, hectometer, decameter. Then we have the meter, decimeter, centimeter, millimeter. The smallest ones are on the bottom. The largest units are on the top. So again, you can do this by multiplying and dividing by factors of 10. And if you want me to explain that to you, I can. Most people find this method easier. So, number 1, pretend you are a small person on the steps. You start on the step that matches the unit given. All right, so we're starting with 75 meters. So that's our base. So, okay, so here we are. And there we go. There I am. So now I'm going to hop to the desired step. So I'm going to hop to kilometers. So I'm going to go 1, 2, 3 hops. All right, and on your paper, you would just draw the 1, 2, 3 hops. And which direction did I move, left or right? I moved to the left. So move the decimal the same number of places in the same direction. Okay, so I got to move my decimal how many hops? 3. Which direction? To the left. If they don't give you a decimal, then the decimal is at the end of the number. Just like money. If this was $75, you would know to put the decimal point right here. Okay? All right, so now we're going to move it 3 hops. So we're going to go 1 place value, 2 place values, 3 place values, or 3 hops to the left and put our decimal right there. When we do that, we now get an answer of 0.075. So 0.075 kilometers is the same as 75 meters. All right, let's do the next example. I have 95 kilometers and I want to go to meters. Okay, so I pretend I'm a little person. I'm starting at kilometers this time because that was the unit that was given, and I'm hopping to meters. So, okay, 1, 2, 3, 3 hops to the right. So I did my 3 hops to the right. Now I got to take my decimal, and I also move my decimal 3 hops to the right. So again, if they give you a decimal, you have to use the decimal. But if they don't give you a decimal, you start with your decimal at the end of the number, just like you would with money. $95 is 95.00. And we're going to hop 3 place values to the right. So 1, 2, 3. 3 hops, 3 hops. And I have these empty spaces, these empty place values. And so I am going to fill them each with zeros. And then I am going to rewrite my number in order to show the new place where the decimal is. And so my final answer is 95,000 meters. So 95,000 meters is the same as 95 kilometers. If you need practice, please, please, please see me for help.